Hello everyone, let's solve the problem Bad Luck Island. So you can read the entire question. So I'll just summarize the whole question so that we'll understand this one in a very simple way. So what the question states, so it involves calculating the probabilities based on our approach. So basically this is a dynamic programming playlist and we'll be going with the dynamic programming approach, right? So the problem involves calculating the probabilities based on the dynamic programming approach to the simulation. So what's the question? Main question. We are given three values, nothing but rock, scissors and papers. So R, S and P, which represents counts of three different types of objects. Just give me a second. So yeah, we are given three values, nothing but here R, S and P, rock, scissors and paper, which represent counts of three different types of objects, nothing but rock, scissors and paper. What is our main goal? Our main goal is to calculate the probability of each type being the last one remaining after repeatedly removing one object according to the rules of the game. So we know what are the rules of the game. Rock will beat the scissors, scissors beat paper and the paper beats rock. So this is the rule of the game. So what we have to do, our main goal is to calculate the probability of each type being the last one remaining after repeatedly removing one object according to the rules of the game. So that's what the question says. So try to read the question. I have summarized the question as well in a very simple way. So what will be the approach? So the approach that we are going with is dynamic programming. So what we will do initially, the first step, we'll go step by step. The first step, usually, if you have followed the previous questions, you will be knowing. First, what we'll be doing, we'll be going with the input handling. That will be the first step, right? So while writing the code, you'll come to know. The second step will be, we will go with the dynamic programming array. Nothing but we need to store the probabilities for all the states of the game, right? So all the states of the game while playing, we need to store the probabilities for all the states of the game. So the state is represented by the counts of this one. Counts of rock, scissors and papers. So the state is represented by the counts of rock, scissors and paper. So this is second one. We'll be making use of dynamic programming array. Why we are making use of dynamic programming array? So we need to store the probabilities for all the states of the game. So and we know that the state is represented by counts of rock, scissors and paper. First one is input handling, right? So what will be the next step? Third step after this one. The second step, we will go with the recurrence relation. Nothing but we are calculating the probabilities of transitioning between states. So again I'm telling, we are calculating nothing but we are calculating the probabilities of transitioning between the states. Based on what? Based on likelihood of specific interaction. Like this one. Initially I have mentioned a rock will beat the scissor, right? So rock will beat the scissor and other rules of the game. Based on that one, we will calculate the probabilities of transitioning between the states. That one will be third one. Calculate the transitioning between the states. I'll just give transition between the states. TBS I'll give. This will be the third step. After this one, what we will do? The fourth step. Just give me a second. The fourth step will be, we have to display the result, right? After filling the DPRA, the solution returns the probabilities that rock, scissors or paper will be the last one remaining. Nothing but we are filling the this one DPRA in the third step. After filling the DPRA, the solution returns the probabilities that rock, scissors or paper will be the last one remaining. Nothing but the output. Here we are displaying the output. Nothing but we are the solution returns the probabilities that rock, scissors or paper will be the last one remaining. So these are the steps, right? So let's try to write the code and understand it completely. So I'll just remove this one. So let's start writing the code. So initially will be, as we know, we'll be going with the input handling. We'll start by resuming the standard input, and also we'll set the encoding to UTF-8. So I'll just give process this one. Skip encoding hyphen. So the next step, what we'll be doing, as usual, we'll be setting the string to the, we'll setting the input string to the empty string. Nothing but the string will hold all the input, right? And we'll also set the current line to 0. As usual, this will track the current line for reading the input. So initially, I'll just set the input string to empty string. Also, let me set the current line to 0. This is fine. Next, what I'll do, let's collect the input data as it comes in and append it to the input string. This is simple. So I'll just give process.standard input and just make use of on, call the data, just make use of, as usual, I'll just give std, and here what we'll do, we will append it to the input string, right? We are appending stdin, input stdin to the input string. Where is the input string? We'll just give input stdin, right? This one, I'll just copy the same thing and make the necessary changes. Let me come here. So here what we will be doing, when the input ends, we will clean it up by splitting into the array of trimmed lines. Here, instead of data, I'll just give end. So let me remove this one. Let me remove less as well. Instead of stdin, it will be input string. So first what we will do, we will trim. What will trim do? Basically, we are removing the white spaces, right? By making use of trim. So next, let me split. We have to read all the input lines. So line by line. For that purpose, I'll be making use of split of /n. And also, let me make use of map. Here, I'll just consider string. Let me make use of the braces first. This has to be small, yes. String dot trim. So this is fine. I think we are trimming the each line. I mean, we are removing the white spaces from the each line. So this is what we are doing. Next, we will write the function to simulate the reading stdin one line at a time. We have to read one line at a time, right? So that one we'll be doing. Again, the same thing. Function, I'll just give read line. So inside this, I'll just give a return input string current line. We are incrementing the current line as usual. So we'll just return the current line and we will increment. This is nothing but the function to simulate the reading from stdin, right? Standard input, one line at a time. So next step, we will, just give me a second. We'll write a function to convert the string, nothing but the rock, scissors, papers into unique index for the DP array. How can we write that? I'll just give function. I'll just call this one f. Let me take the parameters u, v, w, s, p. So here, this is the formula to map UVW to the 1D index. So what's the formula? U into S plus 1 plus V into P plus 1 plus W. So this is one thing. Next, we will be writing the main function. Nothing but we will be writing the core logic inside this main function. I'll just give function main. So first step, what we'll be doing, we'll be reading the initial values for rock, scissors and papers. Nothing but R, S and P. We'll be making use of, I'll just be making use of the destructuring operator. You can give the individual, you can mention individually as well. So I'll just give read line. Let me make use of split. I'll give space. We need space, right? We are reading first, then we need space, then we'll just map the number as well. Number, the data type, right? Number type. Next, we'll calculate the total number of possible states. Nothing but n using the formula. I'll just write here. This is just the formula to calculate the total number of possible states. This we need to remember. So n equals, this has to be r plus 1 into s plus 1 into p plus 1. So after this, we will initialize the DP array with zeros. So let DP, I'll just give new array of n, and we are initializing this one with 0. I'll just make use of fill 0. So the state where all the remaining elements are rock, scissors and papers has the probability of 1. How can we write that one in the form of code? DP, the function that we have written is f of rock, scissors, papers, as well as s and p, scissors and paper. This one, we can set this one to 1. This is nothing but the state where all the remaining elements are rocks, scissors and papers has the probability of only 1. This one we are representing, initializing this one to the 1, right? Next step, we will iterate through all the possible states in the reverse order. So we are iterating through all the possible states in the reverse order. For that one, I'll just be making use of for loop. So let I equals r. We are iterating in the reverse order, right? So this has to be I greater than or equal to 0 and decrement the I. So next, for let j equals, we are giving this one to yes, j greater than or equal to 0, decrement the j. Next, let me take one more variable. I'll just call this one k. K equals p. Same thing, k greater than or equal to 0 and decrement the k. So this is simple. Next step, we'll calculate the sum of all the possible interactions. So all the possible interactions, nothing but I, j and k in this case. So I'll just give let x equals I into j plus j. So just give me a second. I into j plus j, right? Into again k plus k. Finally, so this has to go into I. This is fine. Next, let's get the probability from the DP array. How can we get the probability from the DP array? I'll just call this one a DP0 as we have already took DP, right? Yeah, we have filled the DP array with this one here. And this one, I'll just call this one DP0. We are getting the current probability from the DP array. So I'll just make use of this one itself. I can just copy the same thing here. It's fine. I'll just type DP of f, function name f we have given. What are the parameters? I, j, k, s and p. So I hope this works. So this is fine. If there are no interactions, then nothing but x equals 0, then we will check specific edge cases. So if there are, again I'm telling, if there are no interactions at all, nothing but if x equals 0, then we'll check for the specific edge case. So if x equals 0 or we can directly write if not of x, right? X equals 0 or not of x. I'll just take not of x. Then if only rocks are left, update the DP array for one less rock. So if only rocks are left, or if only scissors are left, or if only papers are left. So we'll just update the DP array for one less rock, one less scissor, and one less paper. Same thing. This is simple. I'll just, the code is big, but it is very simple to understand. So I'll just give if I greater than j and j equals 0 and k equals 0, then what we will do, I'll just consider dp of here I minus 1. So we have to update the DP array for one less rock, right? First we'll go with the rock, next we'll go with the scissor, and when finally we'll go with the paper. So how can we write this one? I minus 1, 0, 0, yes, and p. So this one will be plus equals this one plus dp of 0. I've given dp of 0, right? So next we'll just give me a second here. Next I'll go with the scissors and papers, right? I'll just copy the same thing. Let me copy the same thing and make the necessary changes. So here let me copy this one twice. Yeah, this is fine. This one has to be if j greater than k, and here instead of j, k equals 0 and I equals 0. This one has to be I equals 0. Then this will remain same. Here first I'll just give 0. The second one will be j minus 1. 0, S and P remain same. This remains same. So the third one, this has to be k greater than I, right? And also I equals 0 and j equals 0. What we will do? Here, let me call 0. 0. This third one will be nothing but k minus 1, S and P, dp of 0. So here I'll come, I'll just give else. Else what we will do? We will apply the transition based on the interactions. So here, if there were no interaction, nothing but x equals 0, then we were checking for the specific edge case. Now, else if there are interactions, then we will apply the transitions based on that interaction. So first one, it has to be rock versus scissors, scissors versus paper, and paper versus rock. These are all the interactions that will happen. So how can we write this one? I'll just give dp, just give me a second, yeah, dp of f. I'll just copy this one instead. So just give me a second. Sorry. Let me copy this one until here. Let me paste it over here. I minus 1. First one, rock versus scissors, right? I minus 1. This has to be j. This has to be k equals dp of 0 into here k into I by x. So let me paste this 2 more times and make the necessary changes. So here instead of I minus 1, this will be I. This will be j minus 1. This one will be k. Same thing into I into j, right? This has to be I into j by x. This is fair. This is finally what I'll do. I, j. This has to be k minus 1. S and p. Into j into k by x. These are all the transitions based on the interactions. So this is fine. So next what we will do, will finally calculate the final probabilities of the each remaining object. So I'll just consider result or answer. I'll just take ANS. So in this case, we are calculating the final probabilities for each remaining object. So I'll just give, in this case, just give me a second. dp of f, 0, 0. Yes, comma. This one. To fixed I can give of 12. So this one I can give. Let me copy the same thing and make the necessary changes. I'll just copy this one twice. Again. Let me remove this one here. What I'll do, this has to be, we are making use of the 12 decimal numbers, right? 12 numbers after the dot. Nothing but 12 decimal numbers. That's why I am making use of toFixed of 12. So you can make use of the math.c as well. I have directly made use of toFixed this one. So here I'll just change 0. This has to be 0, 1. All other things remain same thing, right? 0 SB. This has to be 00 and 1. Here I'll change this one to 1. Send p toFixed of 12. This is fine. Finally, we have to output all the probabilities. So for outputting all the probabilities, what I'll make use of? I'll just make use of the console log here. I'll just give, sorry, did I miss something? Console log of answer, ANS, right? So let's join, as we are making use of the string, let's join all the, by making use of the single space. So just give me a second. Did I miss anything? No, right? So here I have to call the main function. So this is fine, I think. Just give me a second. Yeah, this has to work now. I'll just take this input. Let me copy this one and paste it over here. Let me run. So this is giving correct output, right? 0.33. We have considered toFixed of 12. So we are getting the decimal places 12. Decimal numbers toFixed 12. So we are getting 12 numbers after this one dot. So this one is correct we are getting. Let's check for another input as well. So here I'll just give 2, 1, 2 and let me run this one 0, 1, 5, 3, 0 and 5, 5. So 1, 5, 3, 0 and 5, 5. Let me check for the last input. This has to give 0, 5, 7, 6, 5, 2, 8. So let me check this one. I hope this one, yeah, 0, 5, 7, 6, 5 and 2, 8. We are getting the correct output, right? So I'll just copy this one. Just give me a second. So yeah, I'll just come here. Let me click on submit code. So problem D, right? So yeah, I'll just choose problem D. Let me paste the solution over here. Hit the submit. So let's wait for some time. So yeah, this we are getting accepted, right? So the code works absolutely correct. So the code is bit lengthy, but it is very easy to understand. So yeah, this is it. Thanks for watching, guys.